happy to answer them. I hope you're all staying safe and are learning a lot from the course so far. So it looks like this week we covered the like a very basic intro to Python, to installing Python packages, and to doing some very basic things with Python. Please let me know if there are any issues you are having, or if anything's unclear, or if you'd like any additional information about anything that was covered this week. And I'd be more than happy to provide it. Oh, great question, Owen. So next up, we are going to have a little bit more practice with Python. Then let me actually see. Let me get out of here. Let me stop my screen share for just a second. I can actually walk you through some of what is coming down the pike. So let me see. Cool. So here, so week 5, you're going to have more of a Python primer. So let me actually share this with you. Let me share my screen with you. So this will be open tomorrow. So we have another Python primer. Basically, it's going to be about data structures in Python. So how to create and work with lists, how to work with numbers, how to work with strings, how to work with tuples. So that is next week. So basically various data structures in Python. Then week 6 is more Python. So this is going to actually have, I think, more about control flow. So you'll have a little bit about dictionaries, actually another basic data structure in Python, and then Boolean logic in Python, conditional statements. So if, then, else. So that's more of the control flow stuff I was talking about. Function creation, and that's it. So basically, these next 2 weeks, the way to think about these next 2 weeks is you have more work with data structures. So that's this coming week, and then control flow and function creation next week. And then after that, it actually gets to a little bit more of, or leaving Python and moving into more data related asks. So you're going to be dealing with data and decisions. So looking at correlations, looking at how to understand distributions, whether your distributions have skew. And then, yeah, so that's week 7. And then following that, you get into the really fun stuff. So basically weeks 8 through 12 are going to be a lot more of machine learning related topics. And then weeks 13 through 17 are going to be more around optimization and solving optimization problems. So lots of exciting stuff coming. Oh, right. And Owen sent that question just to me. But yeah, he was just asking, he was wondering what is coming up next. So, I can actually give you guys some resources. Let's do that. I'll give you some resources for the what can be helpful in terms of learning some additional things in Python. So, the first resource that I actually really like for Python, there's actually a free version of the book. Is called Automate the Boring Stuff with Python. So this book, sorry, let me find it for you. Oh, Danny, oh, that's a great question. Let me get to that in just a second. That's such a great question. So, automate the boring stuff. So this is really excellent. Okay. A really excellent book. You can actually get free PDF versions or like free online versions of the textbook you can work through. Incredibly useful. So Danny asked a really excellent question. She asked, how would a manager benefit by the use of Python instead of Excel? Is this a tendency and will Excel be replaced? So I personally think that no, and I think Excel definitely has its place. So ultimately, if you need to perform a really quick analysis on a small data set, let's say you just need to create a very quick bar chart and the data set is small. Basically, it can fit without too much effort onto your, basically it can be opened in a single Excel spreadsheet. So you're thinking about less than, let's say, 1 million rows, right? I think right now, Excel, I think can handle up to about 1 million rows of data. And if you want to be able to access all of the data that you have, be able to see all of the data that you have in one spreadsheet, Excel is definitely the way to go. So I have no problems using Excel. I've become more and more proficient with Excel as time has gone on because I think a lot of people, use and are much more comfortable with Excel than obviously than these more newfangled programming tools. But you're eventually, if your data sets get large enough, you're going to hit a wall with Excel. So the first wall you're going to hit is around data size. So if you have a data set and you need to be able to run some analysis on it, and it has, let's say, 5 million rows in it, or let's say it has 10 million rows in it. Let's say it's reasonably large. You're not going to be able to load it into Excel. So that's kind of the first wall you're going to hit. The second wall you're going to hit is when you have to create a semi-complicated data aggregation or data analysis, where the kind of aggregation that you have to do is not as trivial as, let's say, just a pivot followed by a sum on some column, or a pivot followed by a, I don't know, a mean on some column. So basically, as soon as you have to perform non-trivial aggregations, you're basically stuck with Excel. It's really hard to do. You have to kind of start becoming an Excel guru to be able to perform non-trivial aggregation of data. The next kind of place where you're going to hit a brick wall is if you're ever required to actually create some kind of a predictive model where you start with raw data that isn't in exactly the format that you need it to be in order to generate that predictive model. So I'll give you an example. So let's say you are trying to, to create a model that computes lifetime customer value based on let's say, a database of transactions, or a table of transactions that you have, transaction histories for your customers. Okay, so in this case, basically, the raw data that you have, every row that you have is going to be a specific transaction, not a specific customer, right? You're going to have multiple rows associated with, let's say, a given customer. So you're going to have to go through a process, basically, of processing that raw data and converting it into a representation where each row, instead of being a raw transaction, is some kind of an aggregate across all of the transactions on a per customer basis. So obviously you can do that in Excel, but the sequence of steps, especially if there are any cases where you have to do things like VLOOKUPs, so basically joins across data sets, becomes really cumbersome in Excel. So kind of the whole process of feature engineering can get very cumbersome very quickly in Excel, where in Python, especially using a notebook-like environment, you can kind of streamline and annotate the entire process, where it's not nearly as cumbersome and just clunky. That's kind of the best word I could use. So yeah, so basically, for simple tasks, I think Excel definitely has a place in the kind of in the data analysts or in the data inclined managers toolbox. But I think anytime you have a more complicated analysis that you'd like to perform, I'm not saying you can't. I think if you are proficient enough in Excel, if you're if you've become an Excel guru, I think it's totally possible. But the friction, even for a novice in Python, I think is much lower for learning how to do that in Python once you understand the basics of Python than it would be in Excel. So I think that's the best way I can answer that question. Yeah. Yeah, no problem, Danny. Thank you for asking. It's a great question. I think ultimately, like this is you're learning a set of tools here, right? It doesn't mean that you should just always be using one tool versus another. I think ultimately, the sign of a good practitioner in any field is a person who knows who knows when to use the right tool for the right problem. So, you know, if it's a simple problem, use Excel. If the data set is large, or the problem requires non-standard analytical capabilities, use Python. Okay, so yeah, so automate the boring stuff. Really, really awesome resource for just getting a feel for or using Python to actually for actually useful, interesting things. So this book, the really cool thing about this book is, if you decide if you're interested in using it, basically as you progress through the book, you can actually start doing interesting and useful things with Python. You're not just learning the skill and that's it. You just kind of have a cool little thing you can do. There are actually meaningful projects you can execute. So there's lots of orders you can give to Python. So let me show you some examples of things you can do. So we're going to create a very simple program together, and I'll show you. Hopefully, that will show you that there are other things you can do in Python. So I'm going to start up a Jupyter Notebook session. Or actually, sorry, and I can show you some cool things you can do in Python. All right, so I'm gonna give you I'm gonna show you an example notebook. So hopefully you guys can see my screen. I'm actually going to show you a really simple program we can make. We're going to make a really dumb calculator. All it's going to do is it's going to add and subtract. Okay, it's going to take any two numbers that you give it, and it's just going to add and subtract them and return them to the screen. Okay, so let's see here. So yeah, let's do that. So I'm going to create a function, and then we'll use that function to write a little program. Okay. So let's see here. Result, and then off, and then one. Sure, yeah, we'll do that. So Margarita, what's it looks like you might have had another question. So hopefully you guys can see my screen. So I started up a Jupyter Notebook, and I'm just going to show you, I'm writing a function, and then I'm going to show you just a very basic thing we can do. Okay. Jyotsna, you can use whatever edition you would like. The book is I think there's one of the versions is free, and then the newer editions are I think paid. Ultimately, if you'd like to try before you buy, look at the free edition first, and then if you really like it, you can buy the latest. But ultimately, you probably want to use the latest one because it has the most up to date. It has the most up to date. It's going to have like if there were any errors in previous versions, if there are any updates to packages, you're probably going to want to use the latest version. Yep. Okay. Okay, cool. So if my op equals minus, then, sorry guys, so it's a little early. Return 1 minus 2. Okay. And then, so now what I'm going to do is we're gonna use this function. Let me see. I don't know what the problem here is. Oh, sorry, guys. It's still very, very early. Okay, there it goes. Cool. So, what is the first number? So, num1 or first num. Or what do with these numbers? And then, lastly, I will add a print, okay? And then what we're going to do is operation first num, second num. The result is cool. First number 10. Second number 20. What'd you like to do with these numbers? Let's add them. And there you go. So just a really basic thing you can do. So you can create a little calculator. It's one really simple thing. So I'm actually showing you a bunch of different things you can do in Python. First is you can write custom functions, right? The functions can do really any arbitrary thing. I'm showing you a very simple thing that we're doing in the side of the function, which is we're basically taking two numbers, making sure that they are converting them to integers, and then checking to see what operations you want to be done on those two numbers, and then returning the result of those operations. You can also elicit inputs from the user. Okay, so that's what I've done here. So I'm asking basically from the user a question and getting back a result, and I'm doing something with that result. And then lastly, you can have a whole sequence of things, right? You ask a series of questions of the user. You then do something with all of those inputs that you get from the user, and then ultimately you deliver some result to the user. Obviously, this is a very kind of contrived, very simple example of something that you can do. We can check, for example, to see if, I don't know, we can write a little piece of code that checks to see whether a sentence contains a specific word inside of it. Okay. You can, I don't know, take a document and process it in some way. So you can take a path to some document, load it into Python. Let's say, I don't know, remove the first line, convert its format, or maybe take the document and do some kind of numerical processing on it, generate a chart from it, and then email that to somebody. I mean, there's kind of an infinite number of things you can really do in Python. So I can share this with you guys after the office hours is over. So example Python script. And you can run it yourself if you'd like. But yeah, there's lots of stuff you can do in Python. I don't know, Margarita, if this answered your question, but it kind of it hints at a range of possibilities, hopefully, in terms of what can be done in Python. Okay, so let me show you another another really excellent Python resource. It's called Learn Python the Hard Way. This book, sorry, let me go back. This used to be I don't, okay, well, anyway, let me see if I can find his actual, he used to have a website. I'm trying to find the website. Okay, so let me see here. Here it is, all right. So this is also an excellent resource. This used to be free online. I'm not sure if it still is. But this is another really, really excellent resource for learning to code in Python. So in general, this person who teaches this, the teaching style is a little bit abrasive. So if you're not a fan of somebody occasionally being a little abrasive, the teaching style might occasionally rub you the wrong way, but in general, this is really an excellent resource. So I actually used this when I was first learning to use Python. It's basically just a sequence of very brief lessons followed by exercises that are very deliberate, that you kind of won't go through them. The author does things like, okay, print this, now print this. What happens when you add these two things together? And you're literally supposed to write that code down. And the idea is it gets you familiar fairly quickly with the syntax of Python and what Python programs look like. And I think it's kind of the best way to learn a programming language is by doing. So I really appreciate this this person's approach to teaching Python. And I've shared it. I just shared the link to this in the chat as well. And he actually has a bunch of other things you can learn. So Ruby, another programming language more for web development, C, SQL, JS, so JavaScript, Unix, regexes, which are just a way to find patterns in text. And then I've actually never seen this design. I don't really know what that's about. Okay. What other questions do you, ladies and gentlemen, have for me? Oh, the other while nobody's asking questions, the other thing, and this is mostly free, is Code Academy. So Code Academy, there are a bunch of really useful things you can do here. There are some that are free. I'm almost positive a lot of these Some of these are free. Others cost some money, but they're also really invaluable. Some of the lessons here. So I'll put that in here as well. So that's a great question. So Danny, I think that there are some exercises in the lessons coming up, but I think they're pretty limited because these first few weeks are actually ungraded. There are some exercises, but I think they're pretty limited. I think you kind of have to find, if you'd like to practice Python, I think you're going to need to look at some additional resources like the things that I'm providing here. So I think there are some, but it's like I said, it's pretty limited. What else? What else? What else? So I'm trying to think about other resources. I mean, in general, if you just if you just do a quick Google search for resources to learn Python, some of the things that I just showed you will come up, and then there's probably at this point there are just boatloads of other resources that you can find and use. Those three that I've shown you so far are kind of my favorite. Cool. Great question. It's another great question, Danny. So yes, so when you're, yeah, I mean, ultimately you want to be able to use those tables and graphs and then present them in some way. Those can be exported very easily from Python via various functions. So, for example, a very kind of one of the workhorse libraries in Python is called pandas. Okay, so let me actually show you. I'm going to type that into the chat. So this is a Python data analysis library. So and this library one second though, and I'll get back to your question. So this library allows you to do a lot of these kinds of table-based analyses, and ultimately there's actually a way to export um, to export things from pandas out into other, um, not to other places, but basically, for example, you have a table, you want to create a formatted table, convert it into a PDF, and then save it to disk so that you can put it into a presentation. Or you have a bar graph or a pie chart or a time series chart or something like this. You can export it from Python, again, save it as a PNG or a JPEG or I don't know, a PDF file exported, etc. Another incredibly useful, so I'll send this to the chat. So another incredibly useful, this is something that is also a little bit more common nowadays, is let's say you actually have some data and you want to create some kind of an interactive visualization. So something where you have a set of data and you want to give people something almost akin to like something that you would see in let's say a Tableau dashboard, so like an actual interactive visualization. So you can obviously use Tableau for that, but you can build something like that in Python as well using a package called Bouquet. And Bouquet really allows you significantly more, flexibility in terms of the kinds of charts you can build. So they're actually more interactive. So here's an example of a geo chart. There are entire, let's say, I'm trying to see if there is, right. So there are just much more interactive charts here, right? So you have, right. You can style them in ways and basically link to them. You can basically create a website of these kinds of interactive visualizations for people to look at. So I'll send this along as well. Okay, so Owen, assume formulating questions in terms of probability-based structures comes later. Do you have an example to show? So you've kind of seen. I don't have a ready example immediately available, but you've kind of seen Owen a little bit of this so far. I think one common place, for example, that you can use Bayes structures to understand or to make inferences about data would be in cases where, let's say, you have let's say let's take here's an example. So let's say you have a prior likelihood that somebody will I don't know, that you think somebody will interact with not interact with, but let's say you have a website and you have a kind of a general likelihood that a given user will click on a link on your website. So let's say user lands on your website, and you know from past history that just any user out in the world has a 5% likelihood of clicking on the shop now link somewhere on your website, okay? But you have a model, you have a Bayes-based model that can update that likelihood either higher or lower based on, for example, understanding other features of that user. So for example, understanding what part of the country they're coming from by looking at their IP address, or seeing whether if you've seen that specific user on your website before. And based on knowing what things about those variables can actually update your likelihood that they will click on that link or not. I know that's not a very good or clear example, but the idea is and I think we'll get a little bit more into these kinds of things in the course. But the idea is you have a generally basically a default probability for a given what you think a given outcome will be, yes, no, whatever it is, and you have some basically default probability. You think in general, out in the world, knowing nothing else about a given event, there's a 30% likelihood that option A will happen and a 70% likelihood that option B will happen. But then as a result of getting some new information, you can update that likelihood. Go, oh, well, actually, given this other piece of information that I know, it actually moves from 3070 to 4060. Or maybe it goes in the opposite direction, actually goes to 2080. And based on that fluctuation, based on that change in the likelihood, you can change the way that you deal with that specific event. Yeah, but unfortunately I don't have an immediate example of how something like this can work. If I can see if I can cook up an example, and then maybe next time when we meet, I can work through one. Cool. Yeah, I'll do that, Owen. Well, there's so many cool things in pandas. I'm a huge fan of this library. I use this library almost every day. Sorry, I'm just kind of poking around here. They've also changed the way that their documentation looks. It's much cleaner and prettier now. It used to be a lot a little bit uglier. This is really nice. Yeah, you totally should. And it's actually, you don't even need to install it, Danny. It comes preloaded already when you download the Anaconda distribution. So if you've downloaded, if you've installed the Anaconda Python distribution in the way that they describe in the videos for this week, Pandas comes preloaded. So yeah, so you don't even have to worry about it. It's really cool. It just comes, sure. So, all right, I want to see if I have, let me see a data set. Let me find a data set on my computer and see if that can help. No, that's not it. Well, here I'll so let me find a data set on my machine. One second. So let me find a data set. We can see. Okay, yeah, let's do that. So, so actually, let me see here. So I've just loaded a data set into my Jupyter notebook. So this data set is one of the more famous data sets from in terms of like uh, doing basic kind of exploratory data analyses with already cleaned data. So you can find this data set actually on the on this website. So let me share this website with you. UCI machine learning. So this is the data set that I'm using. So what can you do here? So here's one very, very simple thing you can do. I'm going to actually have to write one more thing. So watch this. Dot. So here is a histogram of the displacement column. Okay. Just a super simple histogram, right? So a histogram measures basically, it shows you the distribution of values along the, or the range of possible values for the column on the x-axis, and the y-axis gives you the frequency. So for values between, let's say, about 60 and 100, there are over 100 examples in the data set. Whereas for values between about 420 and 450, there are only about 10 in the data set. So this just gives you kind of a distribution, but you can change the bins, for example. Let's see here. Yeah, bins. Bins equals 20. Changing the bins gives you thinner bins, right? Another thing we can do is we can compute very quickly the correlation among all of the columns in the data set. So here is the correlation. And if we use another, I'm going to add just one more. I'm going to add one more package here, and I'm just going to show you. I can actually so I can convert the correlation matrix into a heat map. Okay, and it looks like basically that cylinders, displacement, horsepower, and weight are both negatively correlated with miles per gallon and acceleration, whereas they're all positively correlated with each other. So very quickly, we can go from a numeric representation to a visual representation. Other simple things we can do is we can, for example, only look at, so we can look at, for example, the distribution or the distinct values for the cylinders column and the number of times that they appear. So it looks like you have 4-cylinder, 8-cylinder, 6-cylinder, 3-cylinder, and 5-cylinder vehicles. And so now we can say, okay, well, let's take a look, let's generate this same exact distribution, but only for this distribution of displacements, but only for example, cars with 6 cylinders. And so what we can do there is equals 6 dot, we're looking at displacement. And there you go. So this is just for the 6-cylinder cars, the distribution of their displacements. And we can change again. We can change the bins to, let's say, 15. Or we can make it fatter, right? We can only 6. All right. So this is cool. So hopefully that gives you an idea of the kinds of things that you can very quickly do in Python. Yep, my pleasure, Owen. So I'll share this. I'll share this script with you guys at the conclusion of today's office hour. And just here, in order to load this data set, you need to make sure that the path to the data set is exactly what you would expect it to be on your computer. So obviously this path is going to be different for you than it is for me. Another cool thing you can do though, and this I think is really pretty awesome. So check this out. You can actually load it directly from the web. Oh, except it's not right because it's a tab delimited file. So let me show you. Is it not a tab delimited file? So now I'm confused. I don't know what the separator is. Anyway, I loaded the data set in, but it's not processed in the same way as my original data set. Let me see, what does this look like? Okay. Let me just want to see what the, yeah, it looks like it's tab delimited. Huh. Or is it space delimited? Yeah, I'm not sure. Anyway, we'd have to process it. But basically, the point I'm trying to make is that if the data set that you have is properly formatted, or you know how to properly format it by loading it in, you can actually just pass in the path to where the data set lives on the internet. So that's what I did just a second ago, which is another really cool thing you can do. Yeah. So I'll change, just make sure that you basically just make sure that the path to the file matches where it lives on your machine. And I'll make sure that it actually works from the directory that you're currently in. So I'll do that when I send this through to you guys. Awesome. I'm glad you like that, Margarita. Yeah, of course, Margarita. Yes, they definitely are. Yep, all true. So in general, basically the kind of the broad strategy is you obviously load it into something in Python or whatever your favorite language is. Then with missing data, usually there's either you do one of several things. Either you throw out the rows or the columns where the missing data lives, or you do what's called imputation. It's where you fill in the missing values either with the most likely value that you think it might be, or with with basically a marker that says this is a missing value. Other things that you generally do is you take categorical values and you encode them in a way that allows them to be represented numerically. And then the last thing that you do is usually with numeric data, you do some kind of scaling. You do some kind of basically normalization, which we talked a little bit about. I want to say last week or 2 weeks ago. I don't remember. But one of the first office hours we had, I talked a little bit about the benefits of standard scaling your data. Those are kind of the three core components of data processing. First is missing data filling in. Second is categorical value handling. And then the third is scaling. And that's it. Once those three things are done, then you can do whatever else is necessary. Yeah. So yeah, so imputation, categorical value handling, and scaling are the kind of the pillars of data processing. And that can all be done, again, that can all be done in Python. In fact, all of that can be done in pandas. The library that I've been kind of talking about how awesome it is, all of that can be done in pandas. Hopefully that gives you kind of a preview of the way that you do this. Yes, you'll definitely need to do that. That's true. That's a good point, Margarita. You will need to describe how the missing data was handled. And there are some common strategies. One is imputing with the mean, another one is imputing with the median, another one is imputing with the mode, the most frequently seen value. That's usually done with categorical data. And then there are more complicated ways of doing this. So one is called multiple imputation. There's another one called expectation maximization. There's a lot of different strategies for doing that. Okay, I think this is a good place for us to stop, guys. We've had the full hour. Hopefully this was reasonably useful today. Enjoy the rest of your days. I will send this out to our program support team, and they will have this notebook out to you hopefully by the end of the day. Regardless, as always, it's a pleasure. A lot of really great questions, and I will see all of you hopefully next week, same time, same place. So with that, I bid you adieu and see you soon. Bye-bye.